Let's work on writing acid-base equations now. Okay, so now this is the first time you will get to see the curved arrows. Okay, so in any acid-base reaction, your first task is to identify what is the acid and what is the base. Okay, so let's take the first example here. So we have CH3OH plus HI. Okay, and the product is also given to us, which is CH3OH2 positive and then I minus. So HI has gone to I minus, which means loss of H plus. Okay, which means that this must be the acid and this must be then the conjugate base. All right, once you know that this is the acid, then this must be the base. Okay, that's the important thing to identify first. Okay, is which one is your acid and which is your base, because that's how you will start the arrows. Okay, once you've identified that this is the base, then you need to figure out where the electrons are, and the electrons are here, right, on the oxygen. Okay, which is the two lone pair of electrons, okay, that oxygen has. So then what happens is that oxygen will pick up the proton. Okay, and if you look at the product here, here are two hydrogens on oxygen. Okay, which means that oxygen has picked up a proton. So your first thing that you do is you draw an arrow, okay, to pick up the hydrogen from here. The second arrow that you draw is actually from this bond going to iodine, because now these electrons are being transferred to the iodine. Okay, and that is how you end up getting the I minus, okay, over here. So that is your arrows, okay, for the first one. Let's do another one. CH3 NH2 plus HCl to give CH3 NH3 plus Cl minus. Now instinctively, hopefully you know that HCl is the acid. Okay, so right here, acid, then base. So if this is the base, you identify where the electrons are. Again, you start your arrow from where the electrons are. Electrons pick up the proton, base picks up the protons, okay, and then here again you have the electrons going to chlorine. Okay, those are your two arrows that you will need in this case. Okay, now let's do some more. And now I'm going to not write the products first, so we will go ahead and predict the product ourselves. Okay, so here we have OH plus OH minus. Okay, so first of all, acid base, this is the base, hydroxide is always the base, and so here this must be my acid. All right, so we're going to predict the product also. The base goes for the proton. All right, so here this is our proton, so the base, start from the negative, bring the arrow to the hydrogen, and then break up this bond over here, take the electrons to the oxygen. Then we draw out our structure. Now oxygen has the excess electrons, so draw the negative on it. The hydroxide picked up the proton, so here's your new bond that's formed, and then OH. Okay, since you started with an acid, carboxylic acid, this is your conjugate base and this is the conjugate acid. Okay, let's do another one. Now let's take something which is a little bit different. Okay, so let's take CH3 CH2 Cl plus AlCl3. Okay, in this case you don't have any traditional acid and base, which means there's no Bronsted-Lowry acid and base. Here in this case we actually have Lewis acid and base, and these are something that you will have to remember. Okay, because there's a little trick to it. Okay, but it's not like you can see the proton. Okay, so this is the Lewis acid, and it's the Lewis acid because aluminum is in group 3. Okay, and group 3 compounds, so boron and aluminum, they will be Lewis acids. So if this is the acid, this has to be the base. Remember, Lewis acids accept a pair of electrons, and Lewis bases give, okay, a pair of electron. And Lewis acids accept. So that's what we're working on. Okay, even in the other ones we were working on that, but at least we had hydrogens, okay, to look at. But now we don't. So if aluminum is our acceptor, we have to find the donor, okay, and the donor here is chlorine, because chlorine is the one that has all the electrons. So electrons are given from chlorine to aluminum. Please be very careful how you draw your arrow. It should come to the aluminum. And whether you take it to the side or to the top, that's up to you. Okay, that doesn't matter. And then the product would be CH3, CH2, okay, and then we still have the chlorine over here, but now it's formed a bond with aluminum, which still has the 3 chlorines on it. Okay, so now you have this really weird looking structure. Okay, and this is the problem with Lewis acids bases, because it doesn't look like a normal kind of acid base reaction. But because aluminum has accepted electrons, you have to put a minus, and because chlorine has given electrons, it gets a plus sign. Okay, so this is the salt that we get. Let's do another one. And here we have CH3 OH plus BF3. Again, BF3 coming from group number 3, so that is the Lewis acid, and this is the Lewis base then, okay, the alcohol. The alcohol, oxygen has the lone pair of electrons. It goes to boron, and this shows either transfer or forming a new bond. So in this case, this is forming a new bond. So CH3O, do not get rid of the oxygen, of the hydrogen, that is still there. And then we have the BF3, okay, over here. Boron received the electron, so it became negative. Oxygen gave the electron, so it has now a formal charge of +1. So that's the salt that you end up forming. So this is how you would write acid-base equations, okay, where you're showing transfer of electrons going from bases to acids.